a video game that I made in Python. So this is the code for the game, and this game is a clone of the video game Breakout. So if I run it, as you can see here, it prompts me with the start screen that says press enter to play. So once I do that, I can play the game. So as you can see, the objective of this game is very simple. The purpose is to hit all the blocks, and when I hit the blocks, the ball bounces back down, and yeah, so the ball has to bounce around. It bounces off the walls and off my paddle and off the blocks, and when the ball hits a block, the block disappears, and once I have hit all the blocks, then I can win the game. Did I lose the game? Let's play again. So as you could see though, if I lose the game, it will tell me that I lost the game, and I just press enter to play it again, and it resets the field and gives me back all my balls. Alright, well, I'm gonna get it. Alright, so as you could see, you win, and then it says press enter to play. And as we saw the first time I played it, it'll also show you lose if you lose. So now let's just show we're losing. So the ball will bounce off of everything except for the bottom. So it'll bounce off the paddle, and it'll bounce off the sides, and it will bounce off the bricks, but it will not bounce off the bottom, and you lose. Press enter to play. And we could keep playing this as much as we want. But I think you get it from there. That is the complete game. That's how it works. So now let's actually get into the code of this game. And just to start off, this is written in Pygame. And with Pygame, you have a boilerplate code right here, which I wrote. This is just to make a window. So Python has the Pygame library as you import it. And this allows us to create a window, so pygame.init. Now we have this clock here. This clock is to set the frame rate. So the frame rate is clocked at 60. So if you change this, it will go slower or faster, but this is how many frames it will allow per second maximum. And this is a while true loop, so this is the game loop. So it's a bit different. More complicated for this actual game that I have right here, but this is just kind of a window, and it just makes it so that it's always updating the frame 60 times a second. And this code right here is the event handler for user input. Right now, for this code right here, all it does is it allows us to quit the game and leave. So pretty self-explanatory right here. It doesn't have any user controls or anything. We also have a window width and window height. This sets the dimensions of the window. And here's the window right here. It also allows us to have a title right here. And this is the fill of the window, so it's going to be black. So if I run this, you're not going to see very much, but it will open a window. So this boilerplate code right here just makes this window, and within this window you could do multiple things. For one, you can make rectangles. So in this code, the paddle and stuff is actually rectangles. So this is the paddle right here. It's a rectangle. So let's just say we copy this into here, and we could show it. And we have that makes it. And we could also get the where we actually want to see the paddle. And this is going to show the paddle if we could just put it right here. And hopefully it'll show the paddle if I do this. Yeah, so the paddle shows up in this example code. That's because the paddle is a rectangle, and how the rectangles work in Pygame is you have the rectangle, and then you set the dimensions of it, which is 120 by 20. And then these are the coordinates of the top left corner. So it's going to be window width divided by 2 minus 60, and window height minus 100 is just what it's set. So same thing for this code right here. So this code is 150 lines long, and that is separated into several different things. So this stuff right here is just initializations. So we have some libraries which we're going to use. Pygame, obviously the Pygame. Sys handles closing the window. Random is here because when we lose the ball, it sets itself back up in a random position. So that gives us some variety in the gameplay. And then enum is the enumeration library, and that brings us to what's right here is this enumeration. So this is the game state enumeration, and this is used to keep track of what the score is. Like, as you have seen before, when I was playing the game, if I lost the game, it'll say, oh, you lost. If I win the game, it'll say you win. And if I start the game off from scratch, it doesn't say either. And that has to do with this right here. So what an enumeration is basically just an integer value. And that depends off of what returns from the function. So it is an integer value which symbolically represents something, and what it's representing is if we haven't played the game at all, it won't say anything. If we won the game, it'll say you won. If we lost the game, it'll say you lost. And this is important for the home screen of the game. Then we initialize Pygame, as we saw in the breakout in the boilerplate code right here. And we also have this frame clock again. We're setting the window width, the caption. Here's a font right here. The purpose of the font is if we want to write text to the screen as we write out the score and how many balls we have left. That is written in this font. It's just the standard font, so none, and it is 50-point font, so that works for that. And then this font is used when we want to actually write something else, as we'll see later. So also we have right here is the paddle and the ball. Again, the paddle and the ball are both recs, and it has the coordinates here and the dimensions here. So that's where it goes. So this right here is the menu surface, and this is the press enter to play. So this is on the home screen. This is press enter to play, and it is written in the font. So it's written in the font 1. So font 1, and then it's font1.render. So self-explanatory right there. So moving on from that, the game is actually composed of these two functions right here. The first one being menu screen. This is the menu screen, and what it does is it takes you to the menu screen, and it'll stay there unless you press enter. And when you do that, or the return key, because I'm on a Mac computer, but it's the enter key. What it'll do is it'll set play game to true, and that will break you out of this loop. So this is an infinite loop while play game is false. So yeah, play game is true, and it takes you to this game loop. And this game loop has several different things. This is the actual game. So first off, we have the ball speed. So the ball has an X and Y speed. As I said, while playing the game, it goes in 45-degree angles. And that's because the components of it are both set to 5. Though, as we'll see later, if it bounces off something, the sign of one of these numbers will change, but it'll always go in a 45-degree angle just because that's how it works. And then the initial paddle speed is set to 0. This changes when you move the arrow keys to go left and right. And then we have the balls left. Once again, this is how many balls you have. If you lose a ball, it'll go outside the screen and you'll lose the ball. Here's the score. It keeps track of the score. Pretty self-explanatory right there. And play game is true. So this works kind of the opposite. How it does here is while play game is true, you'll play the game. If play game is false, it will break the loop and it will break you out of this function right here. So also we have our wall of bricks. So one thing you could do is you could manually set these up, but how I'm doing it is it's just a list. So the bricks are all in a list, and they're being made in a for loop. So for in range, for x in range. So this makes sure that the bricks are laid out in a 2D grid, as you could see. Yeah, and then what it does is it appends a brick. So the bricks list is initially empty, and it appends it to the pygame.rect list of bricks, I guess. And here are the coordinates, and the dimensions of the brick are 80 by 30. These don't change, but what does change is the coordinates. So each brick is going to be offset by 100 times x or 100 times y. So for each iteration, we have 6 different y values, and that's y times 50. So you're going to have like bricks at 0, bricks at 50, bricks at 100, bricks at 150, so on and so forth. And then for the x value is going to be bricks at 0, 100, 200, 300, like that. And then the ball is just going to set itself up right here, the ball x and y coordinates. This is a method of the rect, so the ball x and ball y. And here's actually the game loop. So as we saw in the boilerplate code right here, you have this event handler. And at a basic level, what it can do is you could exit out when you X out the window. But more than that, we could also have our keys. So in this other function for the press enter to play, we press enter, and that's if we press the key down, it'll go to play the game. It's a bit different for the left and right arrow keys because we also have to set it up so when we press a key down, it will go left or right, but when we press the key back up or when we release the key, as it says here, it'll stop going in the direction that it goes. So it will increase the speed and then it will decrease the speed accordingly. So if we press left, the paddle speed will subtract by 15. If we release left, it will go back up to what it was. Same thing for the right. And that just has to do with that. It's just a bunch of if statements. And then we're going to actually move the paddle in the x direction. The paddle stays in the same y direction because that's how the game works, but you can move it in left or right. So that's what that does. So now we have some ways how we handle collisions. And this right here, what it does is it basically makes sure the paddle can't run into the walls. So if we play this, the paddle can't go into the walls. So we can't go past the walls. And we just lost the game right there. And also what we have here is the collider for the ball. So this also says that the ball cannot go past the dimensions of the window. The ball has to bounce off of the ball bounces off of either edge of the window, whether it be the left edge or the right edge, and it is off the window width. The ball also bounces off of the top of the window, and the speed of the ball is adjusted accordingly. Notice here how the ball does not bounce off of the bottom because it has to fall through, because then you lose the ball. The only other thing that the ball bounces off of is the paddle. So this is actually using the collider of the rectangle rather than just figuring it out based off of the coordinates. So if the ball collides with the paddle, then the ball speed y will be multiplied times -1. So in this way, the ball has a perfectly elastic collision with the paddle if it hits the paddle. And then also the other collision that we have to handle is if we hit a brick. So if the ball collides with the brick, and this is saying for y in bricks, so y is actually a brick. So if ball collides with brick y, which is in the list of bricks, then what happens is that brick is removed. So just to demonstrate the behavior, once again, if we hit a brick, that brick is removed, and the ball the brick is removed, and the ball bounces back down on the y direction. And that's handled here. So the ball speed y goes back down. And then the score also goes plus plus. We've seen this while I was playing the game. And then here's actually how we see if we win the game, is that if the length of the list of bricks goes to 0, then we win the game because we got rid of all the bricks. So that's just this list. To reiterate, if we hit a brick, it is removed from the list, the ball bounces down, the score goes up. And if we get rid of all the bricks, then we win the game. Play game is false, and state is 1. So also, if we lose the game, or if we lose a ball, that's handled by this code right here. If the player loses a ball, or if the ball goes less than the window height, so if it goes, or if it's greater than the window height, because the height is actually measured from the top corner. So if the ball exceeds the window height, that means that the ball goes all the way down. The ball will reset to a random position on the x-axis and the initial position on the y-axis, and then the ball's left decrements. Though if the ball's left is less than 0, we lose the game and play game is false. So these are the two ways to get out of this loop, because the loop continues if play game is true. And play game is only false if we either win the game or lose the game. Pretty simple right there. And then here we're actually drawing the objects on the window. So we're going to fill the window with black, so the screen is going to be black. And then we're going to draw the paddle, as I have explained. And then we are also going to draw the ball. So the ball, though the ball is a rect, in the sense of it having a rectangular collider, it is drawn as an ellipse. So that's handled right here. Pygame.draw rect. So also, just to demonstrate that, so we're going to play the game, and look, so look, the ball is a ball. And we play the game with the ball being a ball. But if we want, for example, we could change this to rect, and now the ball will be a square. Press enter, and now the ball is a square. But as you can see, the ball behaves the same way. It's just a square now. So pretty fun right there. And the game works the same way. And another thing is also the color. So the color is just kind of, you have to give a string that says what color you want each thing to be. Another thing is for the bricks is that the bricks are all different colors. So as you can see, these are red, these are green, and these are orange. So that is determined by this for loop, and it just goes off of the coordinates of where the brick is. So if the brick is towards the top, it's going to be red. If it's lower, it's green. If it's lower, orange. And that's just stored in a string called color. And then we draw the rect accordingly. So also this is for bricks and bricks. So what this whole loop does is it draws all the bricks to the screen. Before we were just making the bricks in, here we're just making the bricks in their list. But now we're actually taking them from the list and drawing them to the screen in the color that they're supposed to be. And that's here, right here. And then also notice how this repeats every single frame. So it does this by, once again, the bricks are in a list. And if we hit a brick, it is taken out from the list. So this code is still valid. And we also have to display the score. And that is then in font 1, and we are rendering the, basically just printing out the text, which is score, and then we are casting the score integer as a string, and it's going to be white. And then notice how we have to have a surface, which is the object of pretty much everything in Pygame is a surface. So we have to basically create the surface object. And now we actually have to display it to the screen using window.blit. And what this does is it just lays it over top of the window. So it lays over top the score and the balls left in the same way. It's balls left, and then we are casting the balls left integer as a string, and it's going to be white. And then we are window.blit, and then balls left surface, so it's this thing right here. And then we are giving the coordinates that we want the text to be at. Once again, the text is displayed at the top left corner, so I kind of have to mess around with that to display it in the proper way. And here we also have pygame.display.flip. This is also here in this boilerplate code. This is just for whatever reason to display the game on the screen. Like, for example, if I comment this out, it won't work. Or it will work, but it's not going to do anything. So, yeah, it says press enter to play, but it's not taking the input. So yeah, the pygame.display.flip is kind of important. Like, for example, if we run it again, now it actually works. I'm not sure why. This is just kind of how I learned it to do like that. And then again, we have the frame clock, and that may make sure it goes 60 frames per second. And this is all within the while loop, while play game is true. So once we're done playing the game, either we've won it or we lost it. And that is the return right here. We're going to return the state of the game. So have we won it? Have we lost it? That's what this function is going to return. And then outside of the function, this is what goes on. So this is actually the game in its entirety, is just kind of these 4 lines of code right here in a very abstract way. So when we start off the game state is game state.haven'tplayed. So as we recall, if it says haven't played, if we haven't played the game, it'll just say press enter to play. It won't say we've won or we lost. But if we lose the game and we've lost all the balls, it'll say you lose, press enter to play. And if we win, it'll say we win, but I don't want to play this game again. So that's what that does. So when we start off the game, it will display the menu screen game state, obviously, as we went before. If we haven't played the game, it won't display anything other than press enter to play. And then if we do press enter to play, the loop on the menu screen will complete, and it will go to this next thing right here, and it will do the game loop. And here we're going to actually play the game, and that will return the game state. If we win or we lost, and then it will go back up in this infinite loop, and then it will say if we've won or we lost and if we want to play it again. And this will continue on infinitely until we close the window, that is. So yeah, that's the game of of my Breakout clone, just the basic overview and demonstration, and thank you for watching.